There are going to be instances in which you're not given anything. They're just like, go, just do it, see what you can see, and try to gain access to the gold that's sitting behind all of these huge vaults and doors and safes and such. Hello and welcome to Introduction to Cloud Penetration Testing SIEGECAST Part 4. In this SIEGECAST, I'm going to walk you through the various AWS-specific methodologies that we came up with here at Red Siege to carry out AWS-specific assessments for our clients. I'm also going to lay out all of the tools that I use pretty much for every single one of these assessments, all of which are going to be open source and free, available on GitHub, except for maybe a few that target AWS from an external perspective. Hello, my name is Douglas, and I'm a senior cybersecurity professional here at Red Siege who specializes in web application penetration testing and cloud. So who is this talk for? Well, I would say any individual that wants to be a pen tester. If you want to get into cybersecurity and you want to conduct penetration tests, it's a lot of fun, I gotta say. You are absolutely going to encounter cloud. It is everywhere. Honestly, every single client that I interact with is using some sort of cloud service provider in some way, shape, or form. And if you don't have experience approaching the various aspects of cloud, your assessments and reports may not be as thorough as your clients want them to be. So far in this series of SIEGECAST, we've covered topics such as where to learn about cloud penetration testing, whether it's getting your hands dirty with actual lab training or just books, videos, weblogs. We also covered some of the various tools that we use for these assessments. We touched upon these methodologies that I'm going to break down in this video from a very high level. And we also talked about why penetration testing within the cloud is absolutely vital in ensuring that every step is taken to secure our clients' customer data. Let's begin with a simple recap of what we've learned about the different types of AWS assessments in this series of SIEGECASTs. I'm going to begin with the internal and external network AWS pen tests. Just simply because they're the easiest. They're not very much unlike internal and external network penetration tests that we've all done throughout history. They're just very AWS specific. So you're going to essentially create a methodology specific to AWS. And what that means is, from an internal perspective, how are you going to access the AWS environment internally? Sometimes my clients will just spin up a Kali instance for me and provide to me VPN access or SSH access with private keys to access that system, and I carry out all of the internal network pen testing from that system. So one of the things I search for is, obviously, I'm going to be using masscan and Nmap, host discovery, service fingerprinting, stuff like that, which we all do in internal and external network pen tests. It's all the same. Instead of looking for SMB shares, I'm looking through S3 buckets, though. So I'm going to need at least some form of S3 credentials, or the system that I have access to should have access to the S3 buckets, at least from an internal perspective. File shares are always a great place to start if you're looking immediately for privilege escalation or lateral movement within your client's environment, because it's not uncommon to find plain text files with credentials in them. And there are services that you can recommend to your clients, like Amazon Macie, for instance, which is kind of, I think, like Spirion, where it's going to look for sensitive information in file shares and file systems that are managed in AWS by our clients within their account. Another thing that I like to touch upon is, during external penetration tests for AWS stuff, I find myself doing a lot of OSINT, which is open source intelligence gathering. I use a lot of online resources to just look for as much information pertaining to my client's AWS environment as possible. And one thing I feel like is always overlooked by pen testers is mobile applications, especially if they're free, right? So for instance, if my client, Acme Corp, for instance, if they have a mobile application, I'll search for it in the Google Play Store for Android, for instance, is the easiest one. So I'm going to talk about that. And then I'll go to like APK Mirror or one of those websites that allows me to get the APK file for that specific mobile application, and then I just decompile it in Debian, and then I just start searching using regular expressions in egrep recursively for AWS API keys. If I encounter any API keys, then I start performing enumeration using those keys. I instantly try to figure out what permissions are applied to that set of keys, and I go through as many services as possible within reason. I prioritize it. I go S3, EC2, obviously secrets manager, RDS even. I go through as much as the high priority, high value target stuff as possible, as quickly as possible with those keys, because most of the time I feel like that's going to yield at least something for at least at the minimum lateral movement or finding sensitive information about the environment, the mobile application itself, the databases it's using. So you just kind of have to tune your methodology to be AWS specific for those two types of assessments. Again, they're not unlike typical internal and external network penetration tests, except for the fact that they're in AWS. External pen tests always have lofty goals, like try to access our PCI environment from an external perspective with literally nothing, which is not uncommon. Like that's happening. Threat actors around the world are breaching people's cloud environments every day. Next up, I'd like to briefly touch upon web application penetration tests that are carried out against web application services or applications themselves that are hosted in AWS. So these aren't unlike typical web application penetration tests, in which obviously you're going to have your Burp Suite extensions looking for AWS keys sent over the wire or hard-coded in JavaScript. You're going to use your Find Comments tool, your Find Scripts tool in Burp Suite, and throw that into TruffleHog. Look for as much sensitive information and API keys as possible, obviously avoiding the third-party API keys. But again, it's pretty much the same as your web application penetration test. It's just going to be AWS heavy, which means you're going to see a lot of AWS services involved. Like RDS, for instance, which is relational database service in AWS. You have your S3, which is simple storage service in AWS. Many other services may be accessed by the application, including Lambda services, which are serverless functions. The web applications will use JavaScript to hook into like an API, which gathers the data somewhere magically in AWS. The goal, I feel like, for me, is almost always hunting for API keys somehow, some way, shape, or form in all three of those types of assessments, which brings us to my favorite assessment, and that is the assumed breach. I feel like the clients get the most bang for their buck with this one because here at Red Siege, we actually built our methodology using the CIS AWS Foundations benchmark and the AWS Foundational Security Best Practices as like a launch pad. And what's awesome about that is these benchmarks are tried and true. Like this is like the OWASP of AWS. In fact, it's even hosted on Amazon AWS in their security hub, both of these. Different benchmarks, right? And the first one, the CIS AWS Foundations benchmark, there's an actual service in AWS that you could recommend to your clients that will continuously monitor for all of the things that you're going to be doing your checks for during the AWS assumed breach, which is awesome. If they're not using that, even if they are using that, as red teamers, we're supposed to show our clients what is versus what they assume is. And what I mean by that is some of our clients may not be taking the CSPM alerts and recommendations to heart. They may not be taking them seriously. So that puts them kind of out of compliance, according to Amazon. And it is our job as pen testers to demonstrate impact. So once you find one of these items, they're not checkboxes. We're not going to put in our report, here's a finding, you do not have this service enabled. For instance, CloudTrail being disabled, right? That's a big one, right? Because, if during an actual breach, our clients may be missing alerts of threat actor activity within their environment without CloudTrail trails, and that if those logs being pushed into CloudWatch, that's one of the easiest examples I can think of because, just carrying out the assessment, they should have received some of those alerts because you're simulating a threat actor in their environment. So while using these two different benchmarks to create our methodology, we obviously baked in our own security control checks. And that's something you absolutely want to do because whenever a pen tester applies imagination to any task, it's going to absolutely defeat a simple vulnerability scanner or a compliance check every single time. That's why we exist. So we actually started at the top of the list. It's kind of like an OWASP top 10, like I said before, but it's in AWS for the CIS AWS Foundations benchmark, and we kind of went from there. We integrated typical network penetration testing stuff and external penetration testing stuff into it. And for the Assume Breach stuff, we integrated pretty much everything that you would do during an assumed breach outside of Active Directory into our methodology. So as mentioned in previous presentations in this series of SIEGECAST, I typically begin AWS Assume Breach assessments from the context of, say, a threat actor who identified API keys, AWS-specific API keys that belong to our clients on the internet. That's not unheard of. Back in the day, before there were checks in GitHub for this stuff, software pushes may have gone under the radar. The software development lifecycle, or SDLC, and the change management process may have been skipped, and keys may have unintentionally been leaked to the internet. That happens. And even without GitHub, those keys can still be leaked in some way, shape, or form. A physical breach of a system that belongs to our client, a remote breach of a workstation that belongs to our client. One of the first things the threat actor is going to do is search for AWS API credentials right off the bat, right? So that's the first one, and like the most efficient and cost efficient, I feel like, and thorough check, because during the enumeration process, as I mentioned before, we're going to be searching through all of the stuff that the CSPM service in AWS is going to be searching for continuously. And if the client isn't even using CSPM, that provides a huge value to them and demonstrates why it's important. Another option for a different perspective for an AWS Assume Breach is allowing the penetration tester access to an EC2, and they go from there. See what you can do if this EC2 were compromised, say through a web application that had a very serious user input handling flaw like SQL injection with remote code execution, or remote code execution, say through asset inventory management. You're using like FFUF, you identify test pages that execute like a command, a ping command that's not being sanitized. Web applications are probably one of the number one targets that threat actors are going to focus on very heavily whenever they have you in their sights. Again, the goal there is to essentially see where you can go from the EC2, what you can find. And again, it's not unlike a typical Assume Breach assessment in which you're kind of also testing their, security controls from the workstation that you may get access to, or the EC2, and also the alerting and detection capabilities of the client. So the final, most sobering perspective that I'd like to touch upon is malicious insiders. Like, that's going to happen. An employee that goes rogue, that has a lot of access in your AWS account. So the way we start with those, again, is with typically just the API keys themselves. And the jump point for pen testers for those types of engagements is not unlike getting the API keys or the leaked API keys, in which we're given the API credentials for the AWS API gateway, and we just go from there, and we essentially do a lot of permission checking. If we find something that is modifiable, we definitely document it. That way our clients can ensure that there's like multi-zone setup, there's backup setup, there's disaster recovery procedures that are carved in stone within their organization. And all of these various jump-off perspectives provide our clients with a huge, enormous amount of insight as to what is going to occur if there is a breach in their AWS account. So finally, one last thing I'd like to briefly touch upon as far as the AWS Assume Breach methodology goes is reconnaissance. So in a standard Assume Breach assessment, say in an Active Directory environment, you may not find yourself doing a lot of reconnaissance, honestly, as far as from like an external perspective, using OSINT resources. And that is actually kind of vital during an AWS Assume Breach assessment. The reason why is, and I find it valuable during like the assessment, when I get to like the last few days and say I'm not finding any really good juicy findings, I want to put something fun in the report, right? I will actually turn to OSINT and reconnaissance, because again, if you can find like, for instance, leaked credentials that belong to one of the employees that is employed by the client, try stuffing them. Stuff them into web applications that are hosted within your client's AWS account, or try stuffing them even at the AWS console. If multi-factor authentication isn't enabled, you may get access, right? And again, looking for the API keys is absolutely essential. In fact, even if you did have a good report, I highly recommend doing the reconnaissance and looking for the API keys anyways, because you may be surprised. Like, it may open up more doors for you, or different doors in the environment that you may not have had access with using the AWS credentials that were provided to you by the client to carry out the assessment. Our methodology is, like I said, it's based off the CIS AWS Foundations benchmark and the foundational security best practices, and we built in our own security control checks, all of which is backed off of super brains here at Red Siege and their experience. But we also have to consider compliance checks as far as like PCI testing, right? If there's a PCI network that's part of our client's AWS account, you know, we may want to check that, right? Or they may be required to check that through, you know, from auditors through some sort of PCI compliance. In any case, whenever you're building out your methodology for your practice, I highly recommend going through those two resources that I mentioned and start there. Like, it's a really good jump off point. It even gives you risk ratings as far as the findings go. And always, always, always ensure that when you're writing up your findings, A, you don't do any plagiarism, and B, you actually demonstrate impact, or at least show some sort of real world example. What's even better is laying out in the actual finding verbiage why this is important. Like, why is this security control important? So say something like, during an actual breach, threat actors may be able to get away with XYZ because your CloudTrail wasn't enabled. And during an actual breach, a threat actor is going to be able to access, you know, XYZ or ABC type of data that falls under XYZ or ABC type of compliance just because Amazon Macy wasn't enabled and you found credentials or sensitive information inside of a shared S3 bucket. Okay, so next up, I'm going to talk about the different phases of AWS-specific penetration testing. And I'm going to break each one down by tool. So for instance, in reconnaissance, right? We already learned how reconnaissance is absolutely vital in an external AWS penetration test and how it could be very beneficial to us during even AWS Assume Breach assessments. So what resources we like to use, we actually covered already in previous presentations in this SIEGECAST series. So it's going to be open source intelligence gathering resources such as Grey Hat Warfare, any website that's essentially going to show us any S3 buckets that were previously known or currently known that are under our client's control in their AWS account. Another one is, so web application penetration testing OSINT resources. Those help as well. A super duper obvious place to look is GitHub and any type of code repository resource that our clients may be using, especially if you can find code and maybe that code, you know, represents an application that is actually deployed in a dev or staging or even production environment in our client's AWS accounts. Another good resource is obviously search engines. You know, you can use Google Dorks. Those help out tremendously when looking for AWS credentials that have leaked to the internet or sensitive AWS specific or even web application authorization specific files. So I've already mentioned the Google Play Store. That is a really good resource, especially if you can somehow get your hands on the actual APK of the mobile application that was made by your clients. Another one, Shodan, is a really good one to use, obviously. You know, you can do searches with like org or net. And then there's finally the OSINT.sh is like an absolute tremendous beast at OSINT. That is such a great resource. So the next phase I'd like to talk about is obviously enumeration. And enumeration, when applied to an AWS external and even internal network penetration test, is again not unlike typical network external and internal penetration tests, where you're going to be using off-the-shelf open source tools to do host discovery and service fingerprinting, any of those tools like Nmap, Masscan, even SSLIs, SSL scan, Gobuster, FFUF, Eyewitness, GoWitness, SIP-related tools, SNMP-related tools. You're going to be using those during those types of assessments. The goal of using those tools is obviously trying to get a good grasp on the actual attack surface, like what is available to you to actually attack. During an AWS Assume Breach assessment, I use the AWS CLI tool for almost everything that I do in that assessment. All of the checks that I do are pretty much performed using the AWS CLI tool. And it's a free tool. It's written in Golang. and it's very easy to install. If you don't have any experience using the AWS CLI tool, I highly recommend checking it out and reading the documentation. It has a very powerful query language, and it's very easy to set up with credentials and different profiles. And what profiles are is essentially chunks of credentials that you can use with different contexts. So every single time you issue an AWS command, it actually reaches out to the AWS API gateway and uses the credentials that you provide either through the command line using the -- profile argument, or the only credentials that it finds or default credentials that it will find in the AWS credentials file that's built out using the AWS CLI tool config command. Now, don't get that mixed up with AWS config service. AWS CLI tool is just an actual binary, and it has a config subcommand. It has an EC2 subcommand. It has an S3 subcommand, S3 API subcommand. So there's a lot that's added into it, and I highly recommend becoming familiar with it before actually embarking on an AWS Assume Breach assessment. Another great tool I like using is CloudEnum, and it's really good at brute forcing or finding S3 buckets that may or may not be owned by my client. So one thing I like doing is once I get a big list of S3 buckets through using any of the tools mentioned, or even using open source intelligence gathering resources, I like to send the client a list of those and have them check the ones that they do in fact manage. That way I'm not attacking or reporting on S3 buckets that they don't own. And this is, again, in an external, you typically almost always get a really good scope defined by your clients, but there are going to be instances in which you're not given anything. They're just like, go, just do it, see what you can see, and try to gain access to the gold that's sitting behind all of these huge vaults and doors and safes and such. So, and finally, the last two things I like to mention that I like using for enumeration is Bash and Python. Python is such an incredible programming language that is so easy to pick up and understand and learn the concepts of object-oriented programming really fast. They're very simple applications and scripts that you could spin up really fast. You can use vibe coding as long as you don't have client information sent into AI. At least I don't recommend that. And when you're using a lot of the tools that I'm mentioning during this SIEGECAST, you'll see that most of them are in fact written in Python, and some of them may have, by the time you're watching this, fallen victim to serious dependency issues. So just be very careful of those. I like to create a standard gold virtual machine that has all of the tools in a working state. That way I can fall back on it if one of the dependencies of a dependency of a dependency decides that it doesn't want to exist anymore in Python. As far as Bash goes, I like to use the expansion operators to do like brute force. Like I can virtually do the same thing as CloudEnum does, that brute forces S3 bucket names just by using a simple word list. So the next category of tools I like to touch upon that we use during AWS Assume Breach assessments are going to be Identity and Access Management, or IAM, scanning tools. And what does that mean? Well, Identity and Access Management is access management, access controls, permissions, authorization. And if you really think about penetration testing, almost every single aspect of penetration testing can be boiled all the way down to unauthorized access. So this is a very big category of tools. And luckily, there's a lot of great frameworks that we can use to carry out these tests. So one tool I really like using is Pacu. Pacu is made by Rhino Security Labs, and it essentially takes AWS credentials and just runs with them and just goes through all the various forms of enumeration for specific AWS permissions that would ultimately land a threat actor with privileged escalation and lateral movement, unauthorized access, either way. And Pacu also has a lot of modules already built into it. You don't even have to make your own modules, really, to carry out a fairly solid assessment. It's a wonderful tool. It's free and it's open source, available on GitHub. And another tool that kind of goes along with that is DSnap. I've had some issues with DSnap. It is a Python tool that allows a pen tester essentially to pull down EFS snapshots and EBS snapshots that they have access to. And that way we can mount them and search for sensitive information, again, to perform lateral movement and privesc. Another great tool we like using is called Cloudsplaining. Cloudsplaining is wonderful. It's spitting out an amazing HTML report that lays out a lot of privilege escalation, lateral movement issues with identity and access management that pertain to the credentials that were provided to you by your client to carry out the assessment. So the HTML report has like accordion expandable sections, and you can easily focus on all of the critical issues and the highs and the mediums first. I've noticed that there's a lot of false positives because the AWS API gateway may respond with a positive response to an enumerated IAM permission check, but when you actually test it, it doesn't work. So as long as we're demonstrating whether or not these findings actually work and you're able to pull off PrivEsc or lateral movement in the report, then I feel like that is absolutely a solid assessment in and of itself. IAM is a very massive piece of what we do during AWS Assume Breach assessments. The next category of tools I like to talk about are basic tools, and that's like SSH, FTP clients, database clients like the MySQL Monitor or MariaDB or the Rita CLI tool, any tool that you can use, a dbeaver, to access databases or any type of service that you have enumerated. I highly recommend using it. Even tools that perform brute force like, for instance, the MSF console SSH login testing. All of these can be absolutely beneficial in helping us quickly identify privilege escalation or lateral movement or even sensitive information or even data governance issues. So unfortunately, that brings us to the end of this SIEGECAST. My friends, I covered a lot of juicy tidbits here as far as the different types of assessments, the methodologies and how they're carried out, how to build your own methodologies built off of the 2 AWS resources in Security Hub, what the number one recommendation should be for our clients being CSPM, almost all of the tools that we use during our AWS assessments, and finally, inspiration. That's what I really hope that you get out of this, is that you're inspired to explore cloud penetration testing, explore cloud assume breach assessments, explore the cloud no matter what. Create a free AWS account and start learning how to set up permissions and policies and services. The more you become familiar with all of this stuff, the easier it is to speak the same language and almost be on the same level as your clients whenever you're conveying findings or talking about the assessments or even during kickoff calls. Like, this is wonderful material and it's so much fun and it's the future. Cloud is everywhere. So thank you so very much for watching. Again, I am Douglas at Red Siege. If you'd like to reach out, you could send me an email. And I sincerely hope that you enjoyed this series of SIEGECAST presentations on cloud penetration testing. Thank you.